All right, welcome to an introduction to pointers. All right, so this is a little bit about pointers, and this is an overview, and hopefully after we do a little more talking about this, you will have a better understanding. So far in this class, we have dealt with the following data types: int, double, and character. Now we've also learned a little bit about a data type called F-I-L-E pointer. So when you've declared your file pointers, what you've actually declared is a pointer. Only what the pointer would point to is not the type of data that we're using all the time in our programs, but it's the data that is associated with a file. Well, you can do the same things with the type of data that we've been learning about. You could have an integer pointer, and in this case, an integer pointer is going to point to an integer. A double pointer, and a double pointer is going to point to a double, and a character pointer is going to point to a character. So now instead of only knowing 4 data types, we're now going to know about 7. Now it's very important to understand that if you have an integer pointer, that integer pointer must point to an integer. You cannot have an integer pointer point to a double or a character pointer point to an integer. It's very important to understand that you have to be consistent in the type of data that your pointer is pointing to. A file pointer points to a file. So there's a couple of things to take a look at here. In this right here, this is a declaration of an integer and assigning the value 25 to it. This is the same thing we've been doing since the the beginning of the semester. You can declare an integer, a double, a character, and you can assign values to those variables. This right here is declaring an integer. If you can see that asterisk that I covered up there a little bit, okay. This is declaring an integer pointer. So what this is, there's a difference between an integer and an integer pointer. An integer is an actual piece of data that you have given it a name to that stores and holds an integer. An integer pointer, which would be this, an integer pointer, yes, you can give it a name. This is just a name that's made up, item pointer. But an integer pointer does not store integer data. What an integer pointer stores is it stores an address, or in other words, a location in memory of an integer. Okay, I'm going to draw a diagram of this in the next slide, but I'm just giving you the overview. So what happens here is an integer stores data, like an integer stores a whole number. A character stores data, like a character stores a single character. A double stores data, like a double would store, a floating point number. But a pointer stores an address or location where that information is stored in memory. In order to access anything within a program, it must be stored somewhere in memory. Now, a language C allows you to do something very powerful. And what it allows you to do, it allows you to take a variable, like we have this integer num. So we have this num. This right here, num, this is an integer. We can take this symbol, ampersand, that's an ampersand, and put the ampersand in front of any variable. You can put it in front of an integer, a double, or a character. And what that's going to do, it's going to change this variable that used to be an integer and change it and turn it into an integer pointer. So this is an integer, and this is an integer pointer. Now I'm doing the examples right now with integers, but later I will do examples with doubles and characters. So this can be done with any of the data types we know so far, int, double, or char, but I'm just going to focus on one data type right now to make it simpler. So let's go to the next slide and draw a diagram of this. All right, let me get a different color that works better here, like yellow. All right, so first I'm going to start out by drawing a memory map. So this is a memory map. What this represents right here is your RAM in your memory. Now this would be the beginning of your RAM, and you have gigabytes of RAM, so you have lots and lots of RAM in your computer. And so let's just say this little section right here. So RAM is broken up into pieces. These pieces store data in your program. So depending on what type of data is stored at each location, it depends on how large the pieces are. It also depends on how the memory is allocated, how it's stored, what kind of memory scheme is used. But no matter what, in order to access any data in a program, it's all going to have a location. So keep that in mind. When I say the word address, I mean the location in memory. So as an example here, say I'm in my main function here. This is not complete code. This is just a little snippet of code. And I declare that variable int num, and I assign it the value 25. So this statement right here, what this statement right here does is it allocates me a piece of memory. It allocates me a piece of memory that is the size of an integer, however many bytes an integer is. So the operating system is going to go through here and find a location and say, oh, here's a free location right here. And there's a lot that goes into it. There's a lot that goes into how all the different programs are working on the computer together. So as soon as it finds it, it's going to have a location. This right here is an address. This location right here. So this could be location 10, 20, 30, 40. So this could be location 40, just for example. It doesn't matter for what the location is because each time you execute a program, it's going to be in a different location because different things have been happening in the computer. And if I execute a program on my computer, the same program that you just executed a few minutes ago on your computer, that variable num is going to be at a different location. It's always going to be somewhere else because there's all kinds of different things going on a computer, and that's part of the job of your operating system is to manage that. So what happens here is it finds this location in memory. This is the address. And it says, okay, I have this free spot right here. So this is where I'm going to put this variable num. And this variable num has a value of 25. So that's all that happens right there. If I declare another variable, int num2, and assign it the value 100, then the operating system is going to locate an empty space in memory. Maybe it's going to be up here. You never know. And it's going to say, okay, I have this empty spot right here. I can put num2 right here. It has a value of 100, and it's going to have an address. And that's just the way it works. So this num right here, your computer knows nothing about this word num. We know about this word num because we are using this high-level language, and your high-level language goes through the process with your compiler and your interpreter and all of that. And actually, the way that the computer accesses stuff is by where it's located and its data type. All right, so this is num1 and num2, and they're in memory, and they both have locations. Now, in order to find out what that location is, all you have to do is put an ampersand in front of it. And that turns the variable num, which was an integer, into an actual address. So if you put an ampersand in front of num, then you get what this value is right here. This value right here could be, like I said before, this could be location 40. Could be location 40. Could be location 40. Could be location 40,000. And with each execution, it doesn't really matter because it's going to be at a different location. And we don't care exactly what the numerical value of the location is. We just care that num is located here and num2 would then be located here. So how would we find out what the address is of num2? You put the ampersand in front of it and you say address of num2. Okay, so the other thing I wanted to explain right here is declaring a pointer. Now, when you declare a variable, an integer or a double or a character, you actually get a piece of memory, and that piece of memory is real and it exists, and if you assign, and it has data ready, you know, if you assign it a value, it's going to have data. If you don't assign a value, it's going to be prepared to store that data. So there is actually memory gets allocated by this statement right here. Now, if I declare a pointer like int item pointer, now this is declaring a pointer to an integer. So when I declare a pointer to an integer, I don't actually get a piece of memory for an integer. What I get is a pointer. Now this pointer, I can use it, but the only way I can use it is if I actually tell it to point to a location in memory. And the way that you do that is through an assignment statement. So I can say here, I want my item pointer that I just declared to point to the location in memory where num is. So that way, now my item pointer is then going to point to this location in memory. Then I can reference this data right here, either by the variable num or by going through and what's called dereferencing item pointer. And the way that I dereference item pointer is I put an asterisk in front of it. So I can change a variable into an address by putting an ampersand in front of it, and I can change an address or a pointer into a variable by putting a that's an ampersand here, by putting an asterisk in front of it. So I can turn num into an address or a pointer by putting an ampersand in front of it, and I can turn item pointer into an integer, because it's an integer pointer, by putting an asterisk in front of it. So that would be value at. That's how you read this. You read it as value at item pointer. All right, so let's go back and look at the other slide where we were declaring the nums and the pointers. All right, so let's take a look again at this. So right up here, let's make the pen blue. Okay, this declaration right here is, once again, this is declaring a pointer. So what this is doing right here, it's just declaring the capability of pointing to an integer. But if you do not have an integer already declared, there's no point in using a pointer. You must have an integer first in order to have a pointer point to it. This is what we've always been doing. We just declare an integer and we assign it a value. Now, in order to make our integer pointer point to our integer, we use an assignment statement that says, I would like my integer pointer to point to the location where num is located. Now, if we want to get to this 25 right here, and we don't want to do it by using the variable num, we can change our pointer into an integer by putting an asterisk in front of it. So you could say value at item PTR. So that's going to change a pointer to an integer. And if we took num and we put an ampersand in front of it, that's going to change an integer to a pointer. Okay, so this is called dereferencing, or getting to the value at the pointer. And this is getting to the address of the integer. So these are two terms that you want to remember as we move forward through pointers. And again, this is just an introduction, and we will be doing a lot more examples and code examples in the future videos.